Hi everyone, my name is Lingfen Bao from Zhejiang University. The paper I present is a large-scale study of runtime contributor prediction for GitHub projects. This paper has been accepted by TSE and the other co-authors are Xinxia from Monash University, David Low from Singapore Management University, and Gil Murphy from University of British Columbia. And first, I will introduce the background of our study. Uh, Open source projects have many contributors, however, only a small proportion of contributors can stay with a project for a long time. So if we can identify a newcomer, uh, whether a newcomer become to be a long-term contributor early, there are several benefits. For example, project maintainers can take some action to retain more contributors for a long time, and the project maintainer can understand what facts are more important to return contributors, then improve their projects. There are several previous studies to investigate how to predict a newcomer become a long-term contributor. However, these studies are based on a small number of projects and a limited set of information, such as bug report. However, in our study, we use a large-scale data set. That is more than 900 projects on GitHub, and this dataset contains different development activities of developers. And in our study, we defined a long-time contributor to be a contributor who stays with a project for more than a certain time. The time interval between the first commit and the last commit of a contributor to the project. And in our study, we set 3 different time intervals, that is 1 and 2 and the 3 years. In our study, we use a data dump of judge torrent. Judge torrent contains different kinds of developers activities. This shows the tables of judge torrent used in our study, including commits, issues, pull requests, and watch follows. And we select project by the following step. First, we select top 1,000 projects sorted by the number of their stars. Then we filter the projects whose program language is empty. And we also filter the project that doesn't use GitHub as the issue track system, and we also filter the forked project and the delete projects. Finally, we get 970 projects. And this table shows the number of long-time contributor and non-long-time contributor in different time interval in different settings of time intervals. In our study, we build prediction models based on the first month of development activities of newcomers. We extract a total of 63 features in 5 dimensions. Due to the time limitation, I don't introduce these features. You can read our journal paper for more details. I only show these features in very short time. In our study, we want to investigate 4 research questions. The first 2 research questions, we investigate the effectiveness of our prediction models, and in the third research question, we invest the important features in the prediction models, and in the last research question, we invest the effectiveness of the prediction models in cross-project settings. And in the first research question, we use the time series cross validations. We divide the data into 10 no-overlapping windows. We also run several prediction models in different parameter settings. This table, we use AUC to evaluate these prediction models, and this table shows the results. We found that the random forest have the best performance. And in the second research question, we found that the prediction model built on all features have better performance than the prediction models built on a subset of features. In the third research question, we want to invest the important features. We use the following steps to identify the important features which has been used in many other studies. And we found that 8 features are belong to the top 10 most important features in all 3 time interval settings. For example, the feature mouse user commits in the dimension of developer monthly activities. Its cliff delta is less than 0, which means that it has negative impact on developer being a long-term contributor. In the last research question, we want to investigate the effectiveness of our proposed approach in cross-project settings. We have three cross-project settings, that is cross-project, cross-language, and cross-project size. And the result shows that our approach achieves good performance, and you can see more details in our journal paper. We also got some feedbacks for our findings from developers in open source community. In the survey, we ask respondents to rate their agreement on the three most important features found in our studies, and finally, we received about 115 responses in total. And in the survey, we found many responses agreeing or strongly agreeing that they have a big impact on a developer being a long-term contributors. And they also provide three categories of facts, that including project quality, project community, and personal facts. Here are some example comments in the survey. And here is the summary of our study. And thank you.